Hello guys, welcome to your CCNA 200-301, and this is your 10th lesson. This lesson is subnetting. So don't forget to subscribe to the channel if you haven't already, and don't forget to like the video. Also, make sure you share the video, so please like the video. All right, so our first discussion, or in our previous lessons, we looked at what IP addresses are and we saw the subnet mask and everything. We mentioned that the subnet mask gives you a clear idea of how big your network is and should be like. Now, we mentioned that we have class A. So for the address classes that we're going to be using, again, this is more like repetition, but it is very, very essential to what we're going to be discussing now. We mentioned that for addressing, we're going to be using class A, B, and C. And we said for class A, we had a subnet mask of 255.0.0. We said class B had a subnet mask of 255.255.0.0. And we mentioned that class C also had a subnet mask of 255.255.255.0. So these are the three different ranges. For simplicity's sake, we taken just a class A IP address or network address, which was 10.0.0, and we mentioned that the broadcast address is going to be 10.255.255.255. If for some reasons you don't really know how to calculate the broadcast address, I recommend that you look at the previous video, which is talking about addressing, so usable range and broadcast addresses and all that. You can find that in previous videos. All right, so what this means is that between 10.0.0 and 10.255.255.255, we have what we refer to as the usable range. And for a usable range, for say an example, the class A usable range, it could take more than 16 million addresses, which means that we have 16 million and over IP addresses that are supposed to be assigned to different machines. Now, assuming your company doesn't have 15 million addresses, but has maybe 100 addresses, what would happen to the rest of the 16 million? So assuming that's even just 16 million and we reduce it by 100, that's around 15 million and over. So even though it's more than 60 million, let's cap it at 60 million. Let's say we're using only 100. That means we're wasting more than 15 million and over IP addresses. What are we going to be doing with the rest of the addresses? This is going to be in the same range, so we cannot use it for any other network. Let me give you a logical explanation to this. Assuming you build your house and your house is made up of maybe 7 bedrooms, 4, 5, 6, 7. What it means is that for these 7 bedrooms, so bedroom 1, bedroom 2, 3, 4, 5, 6, and 7, these are the rooms that you can sleep in. That's fine. We all understand you have 7-bedroom house, but you have only 2 family members. Just, well, you are 2 in your family, just you and maybe your partner. Assuming for some reasons yourself and your partner, you sleep in 2 different rooms. So this is 1 room for yourself and 1 room for your partner. What happens to this room and in this room and in this room, this room and this room? So logically, what I would have done will be for me to rent them out. What I'm trying to do is I'll rent them out maybe in pairs of 2s, and the last one will be say 1. So I'll say these 2 rooms. I want to give these 2 rooms to someone who wants to rent them, and then I'll give these 2 rooms to another person who wants to rent it, and this one also be given to one person. So basically, you have 1 for your family. So you have an apartment for your family. You have apartment 2 for another family, apartment 3 for another apartment, apartment 4 for another apartment family. What we've done here is that you've divided your network into sub-networks, and that is the concept of subnetting. You have over 60 million addresses. You cannot use all of them in one network. So what you do is you just break them down. It's like you bought um, chocolate bars. So 1, 2, 3, 4, 5, 6 chocolate bars, but you can only have 2 at a time. So this is what you had. The rest of the bars, you would want to sell them or give them out to people. And when you're doing that, we say you dividing or you splitting. And in this case, when we talk about subnet mask, we're saying that you trying to have a network, but you divided the network into sub networks. So you can go to, assuming this is a class A IP address you bought from a vendor. So that was supposed to be taking around 60 million addresses. Because you cannot use it for just one branch, you can divide them into chunks and say, okay, maybe from 1000 to maybe 10.01.255.255. I want to give it to branch A. And then you move to another branch. So maybe you move to another branch, so branch B, and you decide to give branch B, you give them, so from here you say 10.2.0.0 up to 10.2.255.255. Maybe this is what you give into branch B. You do the same for branch C and the others. Otherwise, when you're going for just this big range, it means that if you are assigning this range, it means you're giving all the IP addresses to just one network. But you can decide to split it, give some to one network, so network A or branch A. You can split another one for branch B. And this is the concept of subnetting, so dividing. I hope this is clear. All right, so why do we do subnets? Because we want to avoid wastage, or because we want to there are so many reasons. Going forward, we'll see the other reasons, but it could be for security reasons also. So when we get to network address translation, you could see that we can do subnetting to have some IP addresses, and then we use a public address to also translate into this, translate our private address into public addresses. But it's used for segmentation. Again, you have a big company, you would want to segment the network. So you would want to give a network here, another network here. With the help of subnetting and VLANs, which we'll see in subsequent videos, you will see that we can use these two technologies, subnetting and then VLANs, to be able to segment or divide our network into chunks. And this is the essence of subnetting, to divide or segment your networks into blocks, or to isolate one network from the other network. All right. Going forward, we'll see other reasons and other examples where subnetting will be applied. We have two main types of subnetting. We have the fixed length subnet mask and variable length subnet mask. All right. Let's go back to what we said the definition for subnetting was. We said subnetting is just a way for you to divide your networks into different blocks or into subnetworks. Now, earlier on, we said, assuming we have 10 rooms, so 5 on each floor. So 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. And we have another one. 6, 7, 8, 9, 10. So we can see we have 10 rooms. If for some reasons we would want to divide them into equal chunks, so 2 each, 1, 2, 3, 4, sorry, 2. This is also another 2. Yeah, this is also another 2. So basically what we're doing here is this one and this one is 1. This one and this one is another one, or maybe we could do this one and this one is 1, this one and this one is 1, and then this one and this one is 1. What we've done here is that we've successfully divided the network into 5 different networks, where you have 1 and 2 being one network, we have 4 and 5 being another network, we have 6 and 7 being another network, 3 and 8 being one network, and 9 and 10 being one network. What we can see here is that for each network, we are dividing, we have 2 rooms, or for each network, we have 2 machines. So this is what we call the fixed length subnet mask. The length of each network is the same. Even when we divide it, we divide it in equal chunks. So basically, we have 2 here, we have 2 here in this network, we have 2 here in this network, we have 2 here in this network, we have 2 here in this network. And this is the concept of fixed length subnet mask. Let me give you a practical demonstration when it comes to the real world scenario. Assuming you have a branch or 2 branches of your company, and for each branch, you are assigning maybe 10 machines each. Basically, what you're trying to say is, okay, if I'm assigning 10 machines in, with no assumptions, we can with assumptions being relaxed, we can say that for some reasons, we will only need 10 IP addresses for each branch, because maximum we have one IP address each for one machine. Let's forget about other technologies and other technicalities. Let's say we only want to assign IP addresses to our computers, and we have 10 computers each in our various branches. So what's happening now is, for each computer you have IP address. So if say branch A, we have 10 IP addresses, so 10 machines, that means we have 10 IP addresses for branch A. If branch B, we have 10 IP addresses, so 10 machines, that means we have 10 IP addresses for branch B. So basically, when we talk about fixed length subnet mask, we're talking about a situation where we have the same number of IP addresses, in the network. And when we talk about variable length subnet mask, this is where the numbers in terms of the machines and IP addresses vary with the networks. So going back to our previous example, we had 10 machines or 10 rooms, which means 10 IP addresses are supposed to be assigned. But this is the case. We have 1, 2, 3, 4. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, fixed length subnet mask means that we have to divide them into equal blocks, but variable length subnet mask is saying that we can divide it any way we want, but it doesn't have to be equal. So assuming we want to divide it into only 3 networks. So network A will be this 4. So network A, we have 1, 2, 3, 4. Network B will be 1, 2, 3, 4. So, well, maybe we can say network B will be 3 or 2. Let's say network B is 2 IP address, 2 machines. So network B is, can we say, well, let's also say, so this is 4, and let's say this is 5. Okay, so network B is 5. So 1, 2, 3, 4, 5. So this will be 5, 6, 7, 8, 9, and network C is just 1, so just the 10. So what you could see here is that for each network, we have varying number of machines. For network A, we have 4 machines. For network B, we have 1, 2, 3, 4, 5, 5 machines. And for network C, we have 1 machine. Now, variable length subnet mask is saying, subnetting is saying that when we dividing our networks into various subnets, we don't want them to have the same length, meaning we don't want them to have the same number of IP addresses. And this is the concept of variable length subnet mask, so subnetting. So here, let me give you a logical explanation, say some explanation when it comes to the real world. If you're looking at it from, say, various requirements, assuming your company branches have different capacities. So let's say branch A has maybe 4 computers, so they may need 4 IP addresses. Branch B is having 5 computers, so they may need 5 IP addresses, and branch C is having just 1 computer, which means they may be needing only 1 IP address. That means the sizes of the networks are not the same, they vary, and this is where the variable length subnetting comes in. All right, so the last part, in our previous ones, we mentioned what subnetting was, and we saw that class A subnet mask was 255.0.0.0, and we said the subnet mask gives you how big your network looks like. Now, in this particular discussion, even though we've mentioned that we have fixed length subnetting and variable length subnetting, we're going to be doing an example for just the fixed length subnetting, and then we'll wrap up this session. All right. So when we talk about fixed length subnetting, sometimes you hear people say FLSM, which means fixed length subnet mask. So in order for you to know, or in order for you to divide a network into chunk, you need to have the measurement, and the measurement here is your subnet mask. So assuming we have a class A 10.0.0, our subnet mask is 255.0.0.0. This is just telling you, we already know what subnetting is. If you have an issue, again, go back to the previous video and then watch it. Now, if we say we're dividing it into equal chunks, what it means is that assuming we want to divide it into, say, we want 4 networks, and each network we want 10 PCs. So we want 4 networks, and each network, each with 10 pieces, 10 PCs. What it means is that we need 4 IP addresses for each network. So 4 times 10, that's 40 IP addresses. But again, it may not be 40 because we have to consider the network address and the broadcast address for each network. All right. So we'll see how that works. We'll just work for one scenario and let's see how the others will work. So we're looking for an IP address. So we're trying to create a network that has only 10 IP addresses. So we're looking for 10 IP addresses. All right. So for each network, we know what a network is. And for each network, we have the network address. We have the usable range. And then we have the broadcast address. Now, the 10 PCs here will be the usable range. So we need 10 IP addresses for our usable range. And then we need one IP address for network address because every network should have one IP address that represents the network. And we also need one IP address for our broadcast. So even though we need 10 IP addresses for the PCs, we need one more for the network address and one more for the broadcast address. So technically we need 12 IP addresses. 10 IP addresses because assuming you're working in a company, you need 10 ID cards for each worker. You also need a billboard that represents the company. So it's a billboard. So like it's more like the logo of your company, which is also something that needs the inscription of your company logo. And then you also need one more board, which is the notice board. That's your broadcast address. So basically we need 12 IP addresses. So this is how you work it out. First, you need to know what we call the bits system. So we've seen when we're doing converting from binary to decimal and decimal to binary, we did some 2 power 0, 2 power 1. If you go back to the previous videos, you see how we did that. Now, again, our IP address that we have is 10.0.0.0 and our subnet mask is 255.0.0.0. All you would have to do is we're going to use some steps here and make sure you be writing them out whilst you're doing this. So what we're saying is, first of all, what we're trying to change is this subnet mask because the subnet mask here is what is guiding us to have, how do we call it? That big size of a network. So this is why we have our broadcast address to be 10.255.255.255 because the subnet mask can be converted to the wildcard mask and the addition will give us our broadcast address. All right. So here, what we're saying here is we need only 10 IP addresses. So we may not need this network mask, subnet mask. Well, network mask is still the same as subnet. We may not need this. So what we'll need is what we call the customized subnet mask. We need to create a new subnet mask. So before we can create a new subnet mask, we have to change these numbers into binary. So the first number, which is 255, will be 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. If you want to know how to convert decimal to binary, you have to check my previous videos. This 0 will be 8 zeros, 2, 3, 4, 5, 6, 7, 8. The next one, 1, 2, 3, 4, 5, 6, 7, 8. And the next one, 1, 2, 3, 4, 5, 6, 7, 8. All right. We're saying that we need only 12 IP addresses. So including the network address and broadcast address, we need 12 IP addresses. And this is what we'll do. I'm sure you may have other formulas, but this works exactly the same way. In the previous next one, we may use another example, but so we need 12 IP addresses, 10 for your PCs and 1 for network address and another one for broadcast address. All right. So that's 12. So we're looking for a number, when power 2 power a number, that will give us 12. So 2 power 0 is 1, 2 power 1 is 2, 2 power 2 is 4, 2 power 3 is 8, 2 power 4 is 16. We cannot use this because this is very low. 2 power 0 is giving you 1. We need 12. 2 power 1 is 2. 2 power 2 is 4. We cannot use it. 2 power 3 is 8. We cannot use it. But 2 power 16 is at least okay because it's not more than, it's not less than 12. At least it can take 12. A bit more, but that's comparing the other numbers we've mentioned. If we decide to go for 2 power 5, that's 32. That's too much. So we don't want to use this. So the main one is this guy, 2 power 4. So we realize that 2 power 4 is going to give us 16, which is more than 12, but at least it's okay. It can do, at least we will get a 12 from 16. So this number is what we call the number of bits. So the number of bits. Now, for your number of bits here, we have 4. When we change our subnet mask into binary, we realize we had 1110000. This side represents the network and this side represents the host. Now what we're saying is the number of bits here is just telling you how many bits do we need for the host, because this one is giving us around 60 million and over IP addresses. So we need some number of IP addresses. We need only 12, but technically we're going to be getting 16 here, which is fine. And we're saying that the number of bits that can give us 16 numbers is 4 bits. What it means is that we just have to shade only 4 circles, 2, 3, 4. The rest of it will be changing to ones because they're no more going to be passed. So this is now going to be the host, the host, the host, and the host. The rest of it we're going to be changing to 1, 1, 1, 1, 1, 1, 1, 1, 1. So all the rest will be changed to ones. So now if we rewrite this, we have 1, 2, 3, 4, 5, 6, 7, 8. This is also 8. 1, 2, 3, 4, 5, 6, 7, 8. This is also another 8. 1, 2, 3, 4, 5, 6, 7, 8. And here we have 1, 2, 3, 4. So 1, 2, 3, 4. So the shaded ones are 4. We give them, we still maintain the zeros because this is the only number of bits. All the zeros here represents our host and everyone else represent our network. So now this becomes network, 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 and this 4 will become our host bits. So basically we need only 4 bits for our host. We don't want to have a big network size. We need only 4 bits for our host. So your new subnet mask will be 255.255.255. So 128 plus this 192.224.240. So this is going to be 240. So your subnet mask, your new subnet mask is going to be, for just the 16 IP address, is going to be 255.255.255.240. That's what I will call the customized subnet mask. It's the subnet mask you created after you divided, you decided to have only 4 IP addresses for your network. So basically, this is what's going to happen. Your new subnet mask is 255.255.255.240. And our IP address is 10.0.0.0. Yes? Now, if we are supposed to find our broadcast address, what we do is we have to change this subnet mask into a wildcard mask. Don't forget, it's going to be global subnet mask minus our subnet mask, which is this one. So our subnet mask. So global subnet mask is 255.255.255.255. And our subnet mask is 255.255.255.240. When we subtract, we get 0.0.0.15, and this is our wildcard mask. All right. So yeah, at any point in time, if you want to pause your video, you can pause it and record and then copy the information. I will be deleting it because I'm using the same board. So we have our wildcard mask to be that. So we know how to calculate for our broadcast address. It's just wildcard mask plus your network address. And you realize that once we do that, the size of our network will change. We'll not be having that big range again. So when we do that, we say broadcast address is equal to your network address plus your wildcard mask. So your network address was 10.0.0.0. Your wildcard mask is 0.0.0.255. So when we add, we have 10.0.0.25. Oh, sorry, did I say 255? 15. So when we add, we have 10.0.0.15 as our broadcast address. All right. So now we know our network address and we also know our broadcast address. So in between that, we have our usable range. So our network address is 10 10.0.0.0. Our broadcast address is 10.0.0.15. And in between them, we have our usable range. So that's 10.0.0.1 up to 10.0.0.14. So we have roughly 14 IP addresses, one for, and then one for network, one for broadcast. So 16, 15, 16 IP addresses in total, but we have 14 IP addresses for our usable range. This is how you calculate for subnetting. So in our next videos, we'll be looking at how to divide other ones into 14, 14, 14. And then we'll also look at situations where we'll have different sizes for our network. All right. I hope this has been informative, and I'll catch you in the next video. Thank you very much and see you soon. Bye.